Hello YouTube family, let's provide a solution given this nice exponential equation which is 8 raised to power x plus 2 raised to power x. This is equal to 222. So what is the value of x? Solution. So now from what we have 8 raised to power x plus 2 raised to power x. This is equal to 22. Okay? 8, we can express 8 as 2 raised to power 3. Okay? So in this case, we are going to have 2 raised to power 3 multiplied by, raised to power x plus 2 raised to power x. This is equal to 22. Okay? From what we have here, we can apply the index identity so that if you have a raised to power n raised to power m, this can be expressed as a raised to power m raised to power n. Okay, so let's apply this identity so that we're going to have 2 raised to power x raised to power 3 plus 2 raised to power x. This is equal to 22. Okay, now let's say let 2 raised to power x be k. Okay, we're going to have k raised to power 3 plus k. This is equal to 222. So we have let 2 raised to power x be equal to k, so that we say k cubed plus k, this is equal to 222, so that we're going to have k raised to power 3 plus k. You take this 222 on the left side, you are going to have negative 222. This is equal to 0. Now from what we have, you find that k cubed plus k subtract 222 can be expressed as, this is the same thing as 216 plus 6. Okay, so this is equal to 0. From what we have again, we can have k cubed plus k subtract 216 can be expressed as 6 raised to power 3. Subtract this negative times positive 6. This is negative 6, which is equal to 0. Okay, so let's proceed. Now let's combine k cubed with 6 raised to power 3 plus k subtract 6. This is equal to 0. Okay, so as you can see, k cubed minus 6 cubed, this is the difference of cubes expressed as a cubed subtract b cubed, which is equal to a minus b, a squared plus ab plus b squared. Okay, so that you have k cubed subtract 6 cubed, this is equal to k minus 6, so that you have here k squared plus, this is 6k, okay, plus 6 squared, which is equal to that 6. Okay, so let's combine this with the first part so that we're going to have k minus 6, okay, k squared plus 6k, okay, plus 36, okay, plus k minus 6. This is equal to 0. From what we have here, k minus 6 is common, so we factor out k minus 6, so that we're going to have k squared plus 6k plus 36 plus, this is 1, everything equal to 0. Okay, now from what we have, you find that k minus 6, this is equal to 0, and that means that I can call this one k1. This is equal to 6. Okay, and this is a real number. This is a real root, in other words. Okay, so the second part, we have k squared, okay, plus 6k plus 36 plus 1, which is, this is equal to 0. Okay, so that confirms that we have k squared plus 6k plus 37. This is equal to to 0. That's our quadratic equation, whereby we can calculate the value of k by applying the quadratic formula, okay? From our quadratic equation, we have that a is equal to 1, b is equal to 6, c is equal to that 7. So applying the quadratic formula, we're going to have negative b plus or minus the square root of b squared minus 4ac, divide everything by 2a, okay? But before that, let's check the nature of this quadratic equation by assessing the discriminant value, which is expressed as b squared minus 4ac. Let's check if it is less than 0. So we're going to have b squared, which is 6 squared, which is 36, okay? You can write here. So d is equal to 36, subtract 4, multiplied by 1, times c, which is 37, okay? So this is equal to 36, subtract, this is 37, this is 37 times 4, and this is supposed to give us a value of 148, okay? So we are saying that the discriminant value is equal to 36 minus 4 times 1 times 37. So we have 36 minus 148, and this is equal to negative 112, which is less than 0, okay? So that means that we have two complex roots. We have two complex roots, okay? Which are imaginary roots, okay? These are not real roots, these are imaginary roots. And so for this imaginary root, we apply the quadratic formula as we have expressed here as follows. Applying the quadratic formula, we're going to have k is equal to negative b plus or minus the square root of b squared minus 4ac, divide everything by 2a, okay? From our quadratic equation, a is equal to 1, b is equal to 6, and c is equal to 37, okay? So let's substitute this. We're going to have negative 6 plus or minus the square root of b squared minus 4ac, which is the discriminant value we have here, which is the discriminant value, which is negative 112, okay? Divide everything by 2 times 1, okay? So this is the same as the discriminant value that we calculated, which is b squared minus 4ac. So you're going to have negative 6 plus or minus, okay, the square root of, this is negative 112. Negative 112 can be expressed as, this is the same as 16 times 7 times negative 1, divide everything by 2, okay? Now from here, so we have negative 6 plus or minus the square root of, this is 16 times 7 times negative 1. So divided by 2. Now what we have here, this is negative 6 plus or minus the square root of 16, this is 4, multiplied by square root of negative 1, this is I, multiplied by square root of 7, divide everything by 2, okay? Now from this, we'll have negative 6 divided by 2, plus or minus, this is 4i divided by 2, square root of 7, which is the same thing as, if you simplify here by 2, this is 3, you'll have negative 3, plus or minus, by 2, 1 by 2, 2i, square root of 7, okay? So that means that we have two complex roots here, okay? We have two complex roots, that is k2, this is equal to negative 3 plus 2i square root of 7, and k3, which is equal to negative 3 subtract 2i square root of 7, okay? We have three values of k. We have k1 is equal to 6, which is a real, this is a real root, and we have that k2 and k3. these are imaginary roots. Okay, these are imaginary roots. Now, if you can recall, we have seen that let 2 raised to power x be equal to k. Okay, now from the k2 and k3, we cannot use this k2 and k3 to determine the value of x, simply because we don't have the negative of a logarithm. Because if you get the negative of a logarithm, this is actually undefined. This is undefined, and therefore k2 and k3, this one will not be applicable to determine the value of x. So basically, we are going only to use the real root, which is equal to 6. So you're going to have 2 raised to power x, this is equal to k, which is equal to 6. Okay, so you're going to have log 2 raised to power x, this is equal to log 6. Okay, now from what we have, log 2 raised to power x, this is in the form of log m raised to power n, which we can express as n log m. Okay, so that we're going to have x log 2, this is equal to log 6. We divide both signs by log 2, divide by log 2, and this is equal to, this is actually equal to, this is 0.7782 divided by 0.30103. Okay, so that the value of x here is equal to, this is 2.585. Okay, so let's substitute. Let's check if this value of x satisfies the equation. Okay, again, as you might recall, we have that 8 raised to power x plus 2 raised to power x, this is supposed to give us 222. Okay, so let's substitute the value of x. You're going to have 8 raised to power 2.585 plus, this is 2 raised to power 2.585. This is supposed to give us a value of 222. Okay, and it's true that 8 raised to power 2.585, this will give us a value of 216. And if you say 2 raised to power 2.585, this is going to give us a value of 6. Okay, and this is equal to 222. Okay, and that verifies that the value of x, which is 2.585, satisfies the equation. So thank you for watching, and kindly subscribe. Follow the steps. See you in the next video.